Hello YouTube, so today we're going to look at this robot again. I believe in the last video I was talking about the legs and problems I was having with the foot joints and the hips of the robot. Today we're going to look at how I'm going to address those problems and make this robot actually walk. Let's start out, I guess, with the feet, because I haven't actually done that much with the feet yet, but you could see what's kind of going on here. I have these are 1/4-inch bolts here and here, and what's going to happen is I'm going to have a bicycle brake cable, and that's going to pull this up like that. You could see how effective it is. Just by touching that, I made the robot lean sideways and fall over. Maybe that's not exactly what I want to happen, but it proves that a motion in that direction can cause a robot to move. Well, okay, let's go to the hips now, and here I actually have been doing a lot more work on. I guess you probably could have seen from when the robot fell that it has a hip joint and it can move like that. I'm not going to move it that much because I don't want the robot to fall again. What it has right here is there are 2 joints right here. Instead of getting actual bearings, I just made some out of a piece of pipe. You could see these parts. If I could get the lighting right. There is the bearing holder part, and that is printed out of PLA. And there's the center part. It's this part right here. This is also PLA. All this is PLA. But there is this gray pipe right here. It's one of these electrical conduit pipes. I cut them up because they are relatively smooth, and those are made out of PVC. And that kind of makes the bearing kind of, it's not completely smooth. If it was completely smooth, the robot would probably fall down right now. So I don't really know how good of a bearing it is, but it saved me a lot of money because I already have the pipe, and buying bearings would have been very expensive. Also, I don't think I'm going to need them since this isn't going to rotate, it's just going to move like from here to here. That is about as much of range of movement as I really even want for this. So I think that's fine. It just needs to handle a lot of torque, and it could probably do that. I don't know. We'll see when we test it. You could see how I'm going to actually move the hip joints, and that's going to be using a big gearbox. I've never actually made a gearbox before. This is going to be the first time I actually make a gearbox that's functional on a walking robot or at all. So I had to plan some stuff out, and what I ended up doing is I ended up making this big gear. You could see I made a big gear and then I cut it kind of in half. You could see this gear, it's supposed to be a circle. It could go all the way around here, but I cut it in half, mainly just to save on filament. Also because it's only going to move in a limited range of movement like this. So that's the range of movement that we have, and we are going to use cordless drill motors for this. I have some more of them. Actually, I was looking through my stockpile of metal and stuff, and I found this motor. This motor was actually one of the drive motors, I believe, for this leg, or the other one. You can see it has the piece of metal still that would go down and make the linear actuator. But it was from an older revision of this robot from over a year ago. You can see it, this cordless drill motor. But what we can do with this is it can be the drive motor for the hips. And I actually did test these motors, moving the legs. They actually have enough torque on their own to move their legs like that. But I think gearing them down will be better, especially if it needs any kind of holding torque, which it probably will since the rest of the robot is so slow. So I'm going to gear them down a lot. You can see the first part is this gear right here. This is the gear that I made. It's a PLA gear. And what it does is that the teeth of this gear mesh with this part right here, so it goes like that. And then we have this other big gear, which I am going to actually place another reduction on here, I think. I probably could get away with just having the motor itself have a spur gear, and that would drive this part. See, and then we'd have quite a bit of reduction just from that. But I think I'm going to make another reduction, so it'll have very little torque will be placed on the shaft of the motor. So how it's going to look is, this isn't the exact gear that I'm going to use. But here's some gears that I made a while ago, and it's going to basically sit right back behind here, and there will be another, like for example this gear right here. It will look kind of like this, but not exactly. It'll sit behind here. And as this turns, this will turn a bunch of times, this will turn slower, and this will turn very slow, which is good because this, again, is just going to move a matter of few degrees. And I'm not concerned about this being the part that slows down the robot, because these linear screw joints, they are very slow. So hopefully everything is equally slow and it will actually walk. It is not my goal of this robot to make anything that walks fast, or anything that even walks to anything resembling human movement, or any kind of that stuff. It's just to make a robot that walks. And that's kind of how you have to do things with this. Just because this is kind of a complicated thing to do. I just want it to walk reliably, balance itself, and then we could get on to making it do other things. This robot could probably stand on one leg if I make the balancing right, and then we'd probably get on to making a torso and stuff. Also, speaking of balancing, I think it's kind of important to recognize that you can see that the legs right here, these motors right here, they are sitting kind of towards the back of the legs. So this actually, what this does is, this motor is pretty heavy, so it puts weight on this side of the robot, and that kind of makes it lean this way. So to counteract that, I have these joints actuated right now. You can't really see it that good, but it bends kind of this way, so it balances out the center of gravity. So the robot is kind of squatting in a way, which I'm probably fine with. You still have enough range of movement to walk with that. And I want it to be able to squat a little bit just to balance itself. But I do want to make it kind of balanced just on its own. And to do that, I think I'm going to have the control electronics for the leg of the robot placed on the boxes that would extend kind of outward right here. I could also put batteries here, and that will kind of counteract that way.